Google Kickstart Round G starting now. 4 problems in 3 hours. Okay, finally this appeared. Let me finish looking at this problem first. Interesting. Okay, we know that it must be one of the W values. I'll leave that for now. You just count the number of kicks and starts. Yeah, okay. So we read in a string. So we keep track of the number of kicks we've seen so far. A1 is our final answer. Then we go through every character in the string. If we see a kick, then so if S1 is greater than or equal to size of S1, then and we take the substring from then number of kicks increases by 1. Now we do the same thing for start. If this is true, then you add the number of kicks to the answer. Ah, shoot. Okay. How did I forget to close my Discord? Seems good. 4 minutes, 3 minutes for the first problem. Why is this not loading? Okay. Matrix. You can go down right, or you can go up left. Can you have negative points? No, so you basically take the maximum number in the diagonal. Yeah. Okay, calculate the sum of each diagonal and then take the maximum. That seems like it. So n okay, and then I'll just use a map because I'm lazy. And then for every element in the matrix, map something. What's that something? So what's I minus j is invariant when you go along a diagonal, so and then we add equal to the current cost, and then oh, it can overflow. Okay, that was a good catch. Then for everything inside the map, we max the answer with the second value in the map. It's either dot or an arrow. Yeah, it's dot, okay. I don't remember my C++ very well. Okay, it seems to pass. Judging by the first two problems, it seems like an easier kickstart. Okay, so this problem we're going to need some observations. Okay, this passed, which is good. So we should iterate over the, what's the last one the last wheel that we use. I think start at like some W and then X is our, okay, if Y is our final value, and then if we change to like Y prime where it's bigger, then there might be a few over here where we move it to the right, and then the cost will decrease. So overall the algorithm, okay, so Y will be equal. Let me sort all the X first. So what do I read in first? W and N. I'll just do N and W because it's usually the convention for problems. We sort everything in X. Answer is infinity at first, and then so keep the current answer. So at first the current answer is right? Yeah, okay. And we also need to push everything into like a min priority queue. Long, and then what do I write here? Okay, the vector and then the comparison function. X of I. What do you do? J is the current one we're using. So X of J plus, and then if I is greater than or equal to N. No, if I is positive, then we add W, otherwise. But what values do they start at? Are they one indexed? Yeah, they're one index, so let me offset, change everything to 0 index. That'll be easier to work with, I think. That means I need to keep track of how many are after when I change the cost. So do I have like 2 priority queues? Okay, now think of what happens when we might need to move some in PQ1 to PQ2. So what is that? While the size is positive and absolute value of, if we're better off moving it to the right, then we'll move it to the right. So what happens to cost? Whatever happens already. Over here, we take the minimum of the answer and the current cost. And we subtract it by the old cost, which is this. And then we also need to update. You push this in queue into the second queue. Okay, what else? After this we're done, we need a transition. Transitioning is weird. Wait a second. Okay, so there are these inner elements V, which I don't know how to take care of yet. But and what's the next element? Is xj plus x of I plus w. And while this is greater than the minimum thing in second priority queue, that means we need to pop it. And we need to remove the cost. Yeah, let's remove the original cost, which is we subtract the original cost b2 on top minus x2, and then we add back the next value of x. Okay, I should update it for these elements. Eventually we insert everything in here into the first priority queue. And in the middle, okay, so over here, move this to the left. It increases by how much we move. So that's x of I plus w minus x2. That's how much we move, and then whatever's on the left minus whatever's on the right. And hopefully that's good. It actually took me quite a while, even though the idea was, I feel like it was pretty straightforward. Okay, never actually popped this, so it was stuck in an infinite loop. Okay, why is it not? Two and 8. Okay, let's hope this works. I'll check one last time for potential overflow errors. Seems like everything should work, so let's hope it does. Okay, what's up with this problem? Let's check the scoreboard. Oh, if I actually solve it, then I'll be first, maybe. Merge cards. Wait, how does he choose? Expected value. Oh, you'll pick a pair uniformly at random. So this is a math problem. Oh, we're using doubles. This sucks. Okay, n squared should pass. Nice. Okay. As long as I don't get screwed up by math probability, then I should be good. How many times is something merged? I feel like we can. Is this a DP? The number of times something's merged is, if you don't choose it, then it becomes subproblem n-1. If you do choose it, then it's probably still trivial. Yeah, it's still like, okay, so this is trivial DP. I hope I'm not wrong. So what's n and an a? What's a? A can be kind of big. No, we just need int. And that should be fine. Final answer is 5 times dp of n of I, where the dp array still needs to be calculated. So dp, that's the number of elements and then some position of the row. So we have our base case, which is 0, so we don't need to take care of it. So we start calculating the dp from... Wait, I can actually just pre-process the dp like only once. Oh yeah, okay, that's cool then. So let's try this. I start from 2 and then it goes until max of n. And then okay, we loop through each element. Yeah, okay. And here we calculate dpij. And so how do you do it? There are like multiple cases here. First case is if we can choose some k from 0 all the way to n-2. That's the index of the pair. So n-1 choices, or i-1. Then that's in the end. Then how many choices do we have for? If I is equal to 2, then we have 1 choice. So i-1 choices. For first case, i-1 multiplied by, what did I multiply by? So becomes, wait, is it no, it's j-1. Okay, j-1 multiplied by i-1 j-1. Okay. Yeah, this case is all, no, it's I greater than 0. If I is greater than 0, then we have, could possibly be merged. So, oh, you decrease anyways. If as long as I is less than n-1, then it can be chosen for that pair. No, wait, what? Oh, okay, I need to replace these with j. And then lastly, how many choices do you have over here? So, if j less than n-1, I minus 1 minus j multiplied by. Seems correct. Actually, I have more cases than I need, but yeah, I need to add constants actually. If we choose something here, that means we merged, so. Okay, I'm getting screwed over by math. We just totals up to I minus j. Totals up to j. I mean, something's not right. Is this I minus 2? Okay, I got the right answer, but I'm like very paranoid that the precision won't be enough. Okay, let's submit, and hopefully I didn't take too long on math, which is my weakness. I think I took more time on C than I did for this problem. Pending judgment. So, yeah. Second person was like 20 seconds or something later than me. Oh, okay. Nice, it passed. So, am I first? I think I'm first. This is like only the third time I've been first. I'm still a bit disappointed that like out of the 7 rounds I only got 3 first places. Yeah, like that's not even the majority of the rounds, so I can't go and like I can't like say to someone that I won the majority of Google Kickstart rounds in 2020, which is kind of sad. But anyways, yeah, the problems were easier this time. It's possible to get like a perfect score in 22 minutes, so definitely shows that it was easier. And then there were, I guess it was really hard to make incorrect submissions. I think the pre-tests were strong enough. Like I don't think anyone really got any like penalties for wrong submissions. Okay, and then last thing is, so if you're, yeah, so as some of you may know, I was very lucky 1 month ago. Yeah, it's already been a month. Okay, I was very lucky 1 month ago and I somehow managed to win IOI. So if you're waiting for that video, like, don't worry. It's like, I think I'm still going to like post a video or two about it. But like lately, I've been struggling a lot with MIT classes since like I'm pretty bad at chemistry and physics. Like, yeah, I have to take them again, so that sucks. But anyways, I'll try to get, yeah, just to let you guys know that that video is still coming up. But anyways, thanks for watching.